Okay, well, how are you everybody who is watching this video? I would like to take this opportunity, first of all, before I welcome you into our today's lecture, to say Happy New Year 2025, my physical students and to my online students. Because I have some physical students, then you have to reply the sentence that I would like to say. My physical, electronics and telecommunication engineering students, Happy New Year 2025. Thank you. My online students, Happy New Year 2025. Well, thank you for reply. Thank you for also wishing me a Happy New Year. I believe that from January to December, actually, especially in case of the content creation, concerned about electronics engineering, telecommunication engineering, computer programming, the Word of God, and even fields of basic engineering and scientific mathematics, I believe that we'll have a lot of contents more than even the other year. My name is Olenjolai. It's the first time to meet me. I would like to take this opportunity to welcome you into our departments, into our online school that called the TANZANIA Online Full Technical College, and we have also another online institutions that called the TANZANIA Online Institute of Technology for the undergraduate or for the bachelor students or training students. And this TANZANIA Online Full Technical College, we are training ordinary diploma students. For instance, that this module, we usually teach our ordinary diploma students in electronics and telecommunication engineering at Dar es Salaam Institute of Technology. However, that the contents are very important in departments of electrical, departments of electronics, and even departments of computer studies or departments of computer. So we have the modules, we are in departments of electronics engineering in that online college, and today's module is called the electronics drawing, and we are in chapter 2 that's called the block diagrams. Then this is lecture 3, types of block diagrams. It's just a continuation of what I've introduced in lecture 1 and lecture 2. Just what are the requirements for this lecture? First of all, this lecture is for all level of students, whether you're a beginner, engineering students, or maybe you're a beginner or maybe you are in another field but you're interested with electronics. These contents are very important for you. But for the professional students or intermediate students, also these contents are very important and are worthy for your journey in different industries and even in school. I have some physical, electronics and telecommunication engineering students, and I just want to tell you that in this class or in this lecture 2, we are going to learn the theory of electronics drawing, but also we are going to have almost 6 examples concerned about the theory that we are going to learn, and those 6 examples are the 6 examples of block diagrams. So we like to ask our students to have drawing tools, especially a pencil, a rubber, a sharpener, and even just a pen for the labeling, because we've discussed about that. So we are going to implement what you've learned in lecture 1, in lecture 2, and what you are going to learn in lecture 3. So I'm ready to teach you. Let me know about your readiness. And these are the contents we are creating specifically by using curriculums of United Republic of Tanzania. So, my physical students, how are you again? How are you, electronics and telecommunication engineering students? Well, are you ready for chapter 2? Are you ready for to learn electronics drawing? Are you ready for lecture 3? Well, so I'm ready also to teach you. So let us do the quick review of what we have covered in previous lecture. So the previous lecture, the preceding lecture is, we said that quick review of lecture 2. So lecture 2, it has been actually titled as the main parts, the main parts. So it has been titled as main parts of block diagram. So main parts of the 4 main parts of block diagram. The first main part that we've discussed is actually called it that block. Say block. Say block. And then the second one, I think, is it 4? We discussed it too, Yeah, we discussed it too. In lecture 1, we discussed it too. In lecture 2, we discussed it too. Okay? So in lecture 1, we discussed about blocks, and also we discussed about lines with arrows. So this is our discussions in lecture 1. So in lecture 2, we've been discussing about the other 2 main parts. The first one is called and the third main parts of the block diagrams is called label. And we define what the means of the label. Actually said that what the means of the label? Pardon, so this is the text pardon, or identifier. It's a text or identifier of a particular block or other parts of the subsystem. That is the means of the label. And then we discussed about the label, that actually each block should be labeled. And in that discussion, you said that each block should be labeled. And this label should be labeled, each block should be labeled inside. So we used to label the blocks inside of those blocks. And then another discussion or another part that we discussed about figure number. Sometimes you may have more than one figures or more than one diagrams, more than one block diagrams. So you say that each block diagram should be assigned the number or figure number. Should be assigned the figure number. And then after that we discuss about name of name of the block diagram, isn't it? And then we say that the name of the block diagrams, this we call it overall. So it's a name of overall. So this is the name of overall block diagram. It's a name of overall block diagram. So, and in most cases, it may represent the functions or the theme why we have that block diagram. And today we are going to apply, or we are going to draw some block diagrams, and we actually will be focusing on using, or actual that we will be using all the 4 main parts of the block diagram. So you'll see them. How do we use them in case of the drawings or learning the concepts of the block diagram. So today we are going to learn about types of block diagrams. Say types of block diagrams. Again, class, say types of block diagram. So the questions you might ask yourself, how many types of block diagrams do you have? But it depends, focusing on what? Okay? So you say that in electronics engineering, so this is all about introduction. Okay? So you say that in electronics engineering, there are 2 main types of block diagram. So we have two main types of block diagram. And these, we name them. They have been assigned the following names. The first one is called the general block diagram. General block diagram. The second one is called the detailed block diagram. So we have general block diagram, and also we have detailed block diagram. Class A, general block diagram. Say loudly with passion. General block diagram.
General block diagram.
Say it loudly. Say general block diagram.
General block diagram.
And then say detailed block diagram.
Detailed block diagram.
Say loudly, detailed block diagram.
Detailed block diagram.
So then the questions comes in your mind. What is the meanings of general block diagram? So ask yourself, what the meanings of general block diagram? So let us discuss in short about the first type. So number one, let us discuss about general block diagram. General block diagram. Class A again, general block diagram.
General block diagram.
So you can pause the video, and then you can pause writing down and ask yourself, what is block diagram? What is general block diagram? What does it mean? General block diagram. Have I encountered it in some other electronics modules? Have I learned it in secondary education? Have I learned it in primary education? What is general block diagram? That's the question you have to create, or you have to ask yourself. Okay? So you may define, maybe general block diagram is a general block diagram. Well, you have tried. Okay? But general block diagrams, it has its particular meaning and its particular objective. Sometimes you may define according to its contribution in case of the electronics drawing. So there are different ways or different sources that can define this terminology. But let me just share with you one of the definitions. A general block diagram, a general block diagram in electronics engineering, you have also to specify. You are defining general block diagrams in which context, in which field, in which knowledge. In electronics engineering. Say with joy, electronics engineering. Say general block diagrams in electronics engineering. This is a high level. So this is the high level, and also it is simplified. We call it a high level, or but also it is simplified, a high level, or simplified graphical representation. Graphical representation, an electronic system of an electronics system, or sometimes called a circuit. System or circuit. This is the one of the definitions of the general block diagram. So you can refer yours. What are you thinking about general block diagram? So you can mark for yourself. That's the goodness of college education. So stop writing. Let me discuss in short about this definition. A general block diagram in electronics engineering, this is the high level. Say high level.
High level.
Ask your neighbor, are you high level or low level? But the question is still general. High level in what? Or low level in what? Okay, simplified. And then the opposite of simplified is complicated. Ask your neighbor, are you simplified or complicated? So your neighbor say complicated. So this is a high level graphical representation of an electronic system circuit, or it's a simplified graphical representation of an electronic system or circuit. So class, let us reinforce the understanding. 1, 2, 3, read the definitions of the general block diagram. Now, no. You are not patients who are in hospital. 1, 2, 3, read it loudly. Still yet. It's not a voice of more than 50 students. 1, 2, 3, go. Again, read it. 1, 2, 3, go. I say it 3 times. 1, 2, 3, go. No. 1, 2, 3, restart. Just the first one, the first definition. Thank you. So can you define the meanings of general block diagram without referring or reading from your exercise book? Yes. Keep it up. Okay. Then we have the second definitions of the general block diagram. Separating. Look on the blackboard and listen. A general block diagrams, in other words, a general block diagrams is a graphical representation. Say graphical representation. Of what? Of electronic system. So of electronic system. That shows the what? The main function. Say the main function. Say the main function. And how they are connected. Listen. So this is the graphical representation. Say graphical representation. So it means it's a visual representation. It's a high-level representation. And in that high-level representation, what do we say that? We say that, what are we going to represent? We are going to present a particular electronic system. And during the presentation, the main focus is we have to show the main functions performed within that electronic system. And also we have to show that how subsystems have been interconnected. Means how these blocks are connected together. So you can combine the first definition and the second definition, and actually you can come up with a strong definition of general block diagrams rather than the first one and the second one. Why? Because in the first definition, we can find some keywords which are very important. First of all, one of the keywords, it means that general block diagrams, this is the high level. So it doesn't give details. Right? That's why you call it general. It doesn't give what? It doesn't give what? So it gives us what? General information. Say general information. So if that's the case, we say that, but in the second, we say this is more simplified rather than the second type. That's why you say that it's also simplified. Okay? So this is the high-level graphical representation or simplified graphical representation. What are we representing? A particular electronic system. It might be a simple hello. It might be a simple electronic system, or it might be a complex electronic system. And then in this, it means that we have also graphical representation. We have noticed about graphical representation of what? Of an electronic system or circuit. So the distinctions mean that in first definition we find the keywords high level and simplified. In the second definition, you can find that we have some also important keywords. The first keywords is actual. We say whenever we are drawing the general block diagram, we have to understand the functions, the main functions of the subsystem of that particular system. Okay? And then in the second definition, also it means general block diagrams can give us an idea how those subsystems have been connected. Okay? So you can combine the first definition. When I ask you in exam, Don't give me this definition or this one. You have to combine and come up with yours. That the level or that the good test that you have understood. Okay? And for that case, you might have different definition, but with the same intention and same meaning. And we see you can have different arrangement of the sentence or arrangements of the word. Okay? But if you just copy this one and then, okay, you'll have a uniform response. And I've tested you how you can cram. Okay, well, so that is a very important definitions of the word general block diagram. Before I discuss in detail about general block diagrams, in case you have a question concerning about those two definitions, you may ask. Do you have any question? No. Well, thank you. So now let me try to discuss with you about the characteristics or the features of the general block diagram. So this is the one of the sentence, very important. We say the general block diagram illustrates. The general block diagrams illustrates the main components or the main subsystem or main subsystem. Main or the main subsystem of the either simple or complex electronic system. So this sentence give you another important, or give you the feature, the theme of the general block diagrams. So it can illustrate main components or main subsystems of either simple or complex electronic system. How does it illustrate it? By giving graphical representation, where we are going to use blocks and lines with arrows. Is it clear? Is it clear? Is clear? But also a block diagram, a general block diagrams does not show. So this is one. So this is one. So let's say that these are the note before. This is number 1, and here we have number 2. So he said that the general block diagram. The general block diagram. So the general block diagram shows the relationship. Shows the relationship or signal flow or electric signal flow among the main subsystem. So a general block diagrams shows what? Relationship. Say relationship. Say relationship. Say relationship. We are the human, we have also relation. We used to have relationship. Okay? We can have blood relationship, friendly relationship, academic relationship, business relationship. Okay? So we say that these general block diagrams shows also relationship or electronic signal flow. Say electronic signal flow. We say that in block diagrams we have 3 types of the signal: power signal, analog signal, digital signal. Okay? And the analog signal and digital signal, we can call them information signal together, or data signal. But when we talk about data, we focus more on digital parts. So you can call it information. So simply, the main 2 types of electrical signal are power signal and information signal. But we have two types of information signal. Analog information signal and the digital or data signal. Right? Right? Then, so it's also show the relationship or the signal, electric signal flow among the main subsystem. Among the what? Among the main? Yes, that is number 3. Number 2. Number 3, we say that also the general block diagrams is used to give a broad overview of how the systems works without giving or without describing specific details of each individual subsystem. So the general class say general block diagram. Reinforce again, say general block diagram. So the general block diagrams gives a broad, say broad, Brody, or we call it general overview. General overview. So it gives us broad or general overview. So broad or general overview of how the system, how the electronic system, how the electronic system works. How the electronic system works, okay? Without focusing, okay, without focusing on the specific or more details of the specific or more details about the particular subsystem. Particular what? Subsystem. So this is another important and powerful sentence. What you have there, separating. The general block diagrams give broad or general overview. So it doesn't give details, just to give you an idea. We call it's high level representation. That's why that in case you have your proposed solution, the next stage to represent your proposed solutions by using block diagram. Okay? So when you draw the general block diagrams, it doesn't give you too much of the details, and we'll see some 3 examples that I've prepared to teach you. Then we say that of how the electronic system works. So it doesn't give you too much details about how the details of the specific subsystem works. And also the general block diagrams does not focus on the specific details or more details about a particular subsystem. Why? Because the second type, that called the detailed block diagram, is the one that will be focusing to it means because the detailed block diagrams, it will break the blocks of the general block diagrams into smaller blocks. So once the block of the general block diagrams has been broken into smaller blocks, it means that those smaller blocks give you too much of the details and too much of the simplified information in such a way that you can design and come up with the schematic or electronic schematic circuit diagram. Are we together? Class, are we together? So this one does not give you detail. It just gives you the overview. Okay, this is the general block diagrams of any electronic system. Okay. So it has just 4 blocks. So, but it's still general. You can ask a lot of questions. What does this block represent? What does it? So you just get an idea, but you are still missing details. Okay, but this is the first, or it's the key of electronics drawing. In case you wanted to design or to implement a particular solution, we ask you to think, first of all, to draw the general block diagrams of that system. Okay, class? Is it clear? I didn't hear. Is it clear?
Yes.
Well, is there a question? No. If there is no question, let me present to you or teach you or give you 3 examples of a general block diagram. So get prepared to draw and understand 3 examples of general block diagram. So 3 examples of general block diagram. Block diagram. Block diagrams or block diagrams in electronics engineering. So ladies and gentlemen, I'm going to present to you, and you have to listen. I'm going to present to you 3 examples of general block diagrams. And these examples will give you just overview. It doesn't give you a lot of details. So the first example. So this we call example 1. Say example 1. Say example 1. So the general block diagram, of any engineering, whether a mechanical engineering system or electrical engineering system or telecommunication system or computer engineering system. This is the general example 1 is the general block diagrams of any engineering system. Say the general block diagrams of any engineering system. Say it again. The general block diagrams of any engineering system. Stand up. The general block diagrams of any engineering system. Can you mention any engineering system that you know? The first one, mechanical engineering system. The second one, electrical engineering system. Another one, a civil engineering system. You are within the building. Do you think that's electrical engineer who built this building? Another one, oil engineering system. Computer engineering system, mining engineering system. Another example, mechatronics engineering system. Biomedical equipment engineering system. Another example, chemical engineering system. Another example, renewable energy engineering system. Well, so listen. So this is the sentence. We say that this is not before. Any engineering, whether electrical or electronics engineering system, can be represented by a general block diagram. A general block diagram. So a general block diagram with only 3 blocks, where we call them system. So separating. We are going to use the 4 main parts of the block diagram. The first block is this one. I say stop writing, stop drawing. Listen and watch. This is the first block. It means any engineering system. All the engineering systems that you have mentioned, can be represented by just using a general block diagram with 3 blocks. Whether it is simple engineering system or complex engineering system, from the complicated engineering system that we may call it, maybe it is supercomputer, one of the complicated engineering systems, maybe some kind of satellite communication system. So regardless whether it is satellite systems or automatic or maybe a motor vehicle or electric train, can be represented by using these 3 blocks. So let me just draw the blocks at the first main part. And because we have discussed it, I don't expect somebody to ask me the questions about the size of this block. And then you have another block. So just these 3 blocks. So we have drawn what? I said, Musa. I said stop drawing, stop writing, listen, watch. So we have drawn the what? The blocks. The what? How many blocks did you draw? 3. The second step or the second part of the second main part of a block diagrams, we say line with arrows. Okay? So this block relate to the second block and show the signal flow that the output of the first block will be transferred to the second block and it will be the input of the second block. The output of the second block will be the input of the third block. And this first block will be interfaced with the real world environment, and the second block will be actual interface or interface with the real world. Okay? For instance, this is 1, the first block. So this is the one of the components of the first block. What the names of this one? An eye, right? So an eye, if it is a biological system, or you want just to represent the human body as the engineering system, then an eye will be represented in the first block. Okay? For instance, this is 1, the first block. So this is the one of the components of the first block. What the names of this one? An eye, right? So an eye, if it is a biological system, or you want just to represent the human body as the engineering system, then an eye will be represented in the first block. An eye is represented in the first block. Then, one of the important main part in any biological system is brain. So my brain is represented in the second block. But again, I want to move from my home to B14 to teach you. So I have to use my legs to walk, right? So my legs will be found in the third block. So the first block, we have presented what? The lines. The lines with arrow, right? The third main part, we say what? Label. Say label. You may use capital letters to label the block diagrams, or you may use the lowercase letters. So the first, this block, we can call it input unit. So if you have understood, the I is an input unit of my body. So this is input unit. Say input unit. Say input unit. So you may use the uppercase letters or lowercase letter, because I did not. I expected you to ask me a question. When we label blocks of the block diagram, are we going to use the uppercase letters or the lowercase letters? But you did not ask it. Why? Because you are thinking about DH. When it comes the topic called the DH or TANZANIA time, you shut down everything. Then the next block, this is called the control unit. Say control unit. Sometimes in some systems we call it a system unit. It means control, or sometimes in some of the books you may find it has been written system unit. Means this is the main part of the system. And this block is called the output unit. That's all. So that I say pendo. I will pendo you now. Then the first main part of any block diagram is to assign the figure number and then to name the block diagram. So this one we call it the general block diagram. The general block diagram of any engineering system. Remember that according to the rules or laws of IEEE, Institute of Electrical and Electronics Engineering, the figure number should be written below of the block diagram, and the name of the overall block diagram should be written below of the block diagram. Students, I say, be attention. Let me repeat. We say that the first main part we have to assign the figure number and the name of the block, right, of the block diagram. So if that's the case, you say that, well, this figure number should be always, according to the rules of IEEE, Institute of Electrical and Electronics Engineering. It means the figure number must be written below of the block diagrams, not on the top. Also, the name of the block diagram must be written next after the figure number and should be below of the block diagram. If you want now to number and name a table of results, it will be vice versa. The number for the table of results will be on top of the table of results, and its name also will be on top. Are we together? Those are the rules you have to follow. Otherwise, you'll be completely wrong and nobody will understand what you have been drawing. So, this is a general block diagrams of an engineering system. It doesn't give us too much detail. And if you want to know that it doesn't give us too much detail, let me give you one example. Okay? Let me give you one example of electrical engineering system. Or let's say, let us start with mechanical engineering system. Okay? Do you know a bicycle? What the input of the bicycle? Input unit of the bicycle. One of the input is what? Pedal, right? What the second input of the bicycle? Tire? Chain. Chain is the second input. Okay, because the chain will distribute now. The chain is control unit because the chain will be distributing the energy from the pedals. The second input? No, the brakes will be controlling. Controlling what? Motion. What the second input? Not a tire. A tire is an output. A tire is just like represent your legs. Are your legs are input? So for the bicycle, the second input is a wheel. Is it an input or it's a controlling? I think it's a controlling because you are yes, you are controlling direction. Another input? Not brakes. Another input is gear. Right? Some of the bicycles have gears. You change the gear, then you change the motion. Okay? Yeah. Then for the control, we have mentioned the chain, another part, the wheel, another part, the brake. That's how. That's a mechanical system, right? But you see that you can write. So it means that when you say that the input of the bicycle, this block does not give us details, the one that we are discussing. Then when we talk about output, what are the outputs of the bicycle? The tire, right? If the tire doesn't move, no motion. Right? But the tires, depending on what? External force. Okay? Another output? Brake. So simply, if you fail to mention different parts of the bicycle while you rode the bicycle when you were young, you don't know the bicycle. You just know how to drive, but you don't know how it works. Okay? So that is one example of simple mechanical engineering system. Then mention maybe an engineering system that you know. So we can present it by using these 3 blocks. Mention the one that you might think that I just want. Can this match, or can this system be represented by using those 4 blocks? Mention. Class, mention another example. Mention, Pardon? Calculus? Calculator? You want to ask a question? About what? Ask. Input of the what? Arrangements of what? Yes. Would you think that we can write this output unit? Let me see. No, always the input we place them on the left, and control anything in the middle should be placed at the middle, and the outputs always just placed on your right hand side. And it's a simple philosophy, just like when I'm writing. So this is my input, this is my control, and this is the output. I've completed the line.
Asking that those blocks are written in horizontal line. So can we write in vertical?
No. That's what I answered. You just wanted no or yes, eh? Okay. Or maybe you just wanted. No, you cannot represent them in vertical. Unless you have some other blocks. You can place also some other blocks on top, others at the bottoms. It's just a first example. Don't ask a lot of questions, because I'm trying to open your eyes. You'll get the answers of so many questions in this lecture. Okay, another simple example. Every student in this class has a mobile phone. Say mobile phone. So a mobile phone is one of the complicated telecommunication engineering system. A mobile phone, when it discusses about input unit, then what are the components of the input? The first one is microphone. Say microphone. Every mobile phone should have a microphone, and it's a working microphone. The second example is a camera. Say a camera. And you like 5 megapixel camera, 32 megapixel megapixel camera, right? You like camera because you're a digital age, good quality camera. So a camera is the second input. Another third input, take your mobile phone, because you don't know it. Another third input is what? Screen. Not even screen. The screen is not the input. It's a keypad. Okay? It's what? It's what is called what? Keypad. Say keypad. But remember, the keypad of the smartphone and the iPhone is being integrated with a display. Whether LCD display or OLED display or another types of the display, because you have 3 types of the display in mobile phone. Okay? So another one is what? Keypad. Another example of input. In your mobile phone. You are using a mobile phone. How do you input the information to your mobile phone? Fingerprint. Very good. Clap your hand for him. So fingerprint is an input. Okay, another example, etc., etc. So the mobile phone, it has a number of inputs, right? So all of them, we call them input. Then control unit, we have microprocessor. Say microprocessor. But within it, in this control units, we have a microprocessor, but also microprocessor is supported by other integrated circuits, such as network IC, we have power IC, we have memory IC, Those are the actual, all of them representatives in control or system what unit. Then so it means that the control or system unit, we cannot see it physically. It's not located outside. I said you have to come at 12:30. Gideon, 12:30. It's 12:30 now. If that's the case, what do we say? We say, let us discuss about output. What are the output of your mobile phone? The first output? Speaker. Very good. Clap your hand. Best. So good, better, best. Well, so that's wonderful. So it's the output unit is what? A speaker. The second output unit? A display. Well, that's the second output unit. Another output unit or output components of the mobile phone? A touch. Very good. Clap your hand. Okay, so etc., etc., etc. So you trust our block, our general block diagram now, isn't it? So you can try to take or think any other engineering system and try to think about how can you represent in those three blocks. Example 2. Tell your neighbor we are in example 2. So example 2. This is new year, new style of teaching, new trick. So the general block diagram of any electronics engineering system. So let us narrow the concept. Let us narrow the concept. We were so general in engineering system. Now let us focus in electronics engineering system. Say electronics engineering system. How many electronics engineering systems do we have in real life? Many, right? Then you have to think, how can you represent them in general? So this is not before any or mostly any electronics engineering system can be represented by a general block diagram with only 4 blocks. So electronics engineering is a subset of engineering system. Stop writing. So electronics engineering is a part of this one. So even electronics engineering can be represented in this form. Stop writing. So we have always, whenever I'm trying to teach you in the algorithms, we call it stepwise. Diana. So let us draw what we learned. I said stop writing, stop drawing, look and listen. Musa, you are disturbing. Let us draw what we had learned before in the first example. So we had the first block and this, so we have to draw blocks when you follow about those 4 main parts. This is the first block. Also, you have to make sure that you draw them, or you draw these blocks by using a ruler. You have to make sure that you draw smart or clean rectangles, straight. Okay? Then we had another 3D block. So if it is electronic system, we must also represent it by using another force block. Means that this force block also, it's a must. We must find it there. So you have how many OT? How many OT? The first main part of that general block diagram. Okay? Then the second part, interconnection, means lines with arrows. So lines with arrows, let us draw the previous arrows. Hey, wait. Block is interconnected with the second block by using an arrow. This is the signal flow. The output of the first block, it's the input to the second block. The output of the second block, it's the input of the third block. That's the second part. But you have another block. I say this, stop writing, look on the blackboard. Tell your neighbor, stop writing and stop drawing, look on the blackboard and listen. Then, this is another arrow. And then this block is interconnected with all the blocks. So it's interconnected with all the blocks. Then, this, we discussed about this one. How do we call these kinds of arrow? You forgot, yeah? And what its name? A network arrow. Then, so remember that this arrow is actual, it means this block is interconnected with the first block. This block is interconnected with the second block. And the first block is interconnected with the third block. We are done with lines with arrows. Diana, please. I will punish you. Then, let us label the second part, the third part. Okay? Yes. So to label our blocks, we have what? Input what? Input what? Say input unit. This one, we call it what? Control or what? Control or what? System unit. But now let us just call it just simply control unit. I say the system, I just gave you another system unit because in some of the books you can find it has been named like that. But the common names and the accurate ones, control unit, the brain of the system. Then the name or the label of the third block, we call it output what? Output what? Output what? Unit. Then this first block is called, we are going to label the first block. This one is called the power supply. Whenever you draw a general block diagrams of electronic system without power supply, it's meaningless. Because it will never work without power, or electric power. This system work? Well, the power supply will supply. So I'm going to explain how this system work. I will not write. How will this system work? What the operation principle of this general block diagram? Well, the power supply, first of all, when you turn the circuit on or the system on, the power supply will supply the power into the input unit, into the block of input unit, the block of control unit, and the block of output unit. Why? Because we are expected to have electronics components that need power in order for them to perform the particular function. For instance, we say we have a microphone in mobile phone, because a mobile phone is an example of electronic system. Okay? So we mentioned in this, in example 1, that a mobile phone, one of the inputs of a mobile phone is a microphone. Say microphone. So, for instance, if your mobile phone does not have charge or is not charged, or maybe you have a microphone and no power supply, then there is no, it means the mic will not work. For instance, this is the mic that I'm using right now, just to make sure that I record or I digitize my voice. Well, this is just a mic. This is just what? A mic. Say mic. So this is the microphone. Let us forget, because you may say that your mobile phone doesn't work because, or it doesn't not work because some other parts depends on the electric energy. But this is just a microphone. It cannot do any other things. Just record the voice, amplify and process, then send it to the distant receiver. So when you open this microphone, you see that we have 2 batteries, right? Or we have 2 dry cells. Musa, you're not looking. We have 2 dry cells. So it means that these dry cells is actually providing power into the input unit. Okay? So the first principle of operation, the power supply will distribute the power into the block of input unit, the block of control unit, and the block of output unit. Okay? Yes. Then when you talk about control unit, it's just like your brain. When, for instance, that you are hungry, you didn't eat, you did take some food or some water, then you know what will happen to your brain. It won't function. Right? It rejects to function. Everything will be stopped until the stomach is saved. Similarly, when you talk about the microprocessor that we have in our mobile phones, it cannot work without power. So that's why electric power is important. Okay? Then the second principle of operation, the input unit will actually take the input from the real world environment, process it. After that, it gives the output into the control unit. The control unit will be processing the outputs of the input unit in terms of electric form. After that, then the outputs of the control unit will be sent to the output unit. So we have 4 principal operations for this general block diagram. Okay? And I have explained them. Is it clear? Is it clear? Yes. Okay, good. You are good students. Okay, so the first main part is figure number. Say figure number. This is figure number what? Ask your neighbor, do you like electronics drawing? Ask again your neighbor, do you like electronics drawing? The general block. So what do you like? If you don't like electronics drawing, what do you like? Because you say no. So what are you doing in this class? Because this is the drawing that you are studying electronics engineering. Okay. The general block diagram of any electronics drawing, of any electronics engineering system. If you don't like, I'll try my level best to persuade you to like it. So this is all about the second example. Example 3. Say example 3. So the general example, the general block diagrams of any telecommunication, engineering system. Not before. any telecommunication engineering system so any telecommunication engineering system can be represented by a general block diagram with only 5 blocks. So telecommunication engineering is one of the branch of telecommunication engineering. Say telecommunication engineering. So telecommunication engineering is the one of the branch of electronics engineering. So telecommunication engineering is a child of electronics engineering, and we've discussed that in previous lecture. We call it junction. Okay, so we are going to draw the general block diagrams of any telecommunication engineering system. You are pursuing ordinary diploma in electronics and telecommunication engineering, and that is my responsibility to teach you. Okay, so then we say that, oh, you just need some time to draw this. Okay, I think that, let me give you 1 minute to draw that. Sasa penseli yako ilikuwa nachora engineering drawing, mechanical engineering drawing sana. Kaanza kusema kwamba sasa mbona tuchori drawing zetu? Elia so one of your assignment, you have to think about how you can represent different electronics engineering system by using 4 blocks. So it's a drawing time. Let's go. So example 3, separating the general block diagrams of any telecommunication engineering system. Then not before. Any telecommunication engineering system can be represented by using a general block diagram with only 5 blocks. Read not before. 1, 2, 3. Again, read it loudly with passion, with joy of New Year. 1, 2, 3, go. Very good. Thank you. Keep it up. So this is the keyword. This is another keyword. So let us draw. Tell your neighbor it's a time for drawing. Tell your neighbor it's a time for drawing. Stop, my neighbor, stop writing, stop drawing. Look on the blackboard and let us draw with Olenjolai. Tell your neighbor that sentence. Olenjolai. Okay, so we are going to draw the general block diagrams of any telecommunication system as advancement of example 2. Because telecommunication engineering is a branch of electronics engineering. So let us draw what we learned, and then we see the additions of the 50 block. Okay? Yes. Okay? Yes. So what we had there, we had the 4 blocks. Let us draw the blocks. This is the first block. Then you have the next block. Then you have a next block. This is the steady block. Then you have the first block. So you are going to have the fifth block. I said stop writing. Stop writing, stop drawing. So how many blocks do you have there? The next main part? You forgot. Because you are not there. Lines is, we have to draw lines is what? To show relationship. So let me draw according to the principle of operation. Go trigger. So this block has a close relation with the second block. The first block has a close relation with the first block, with the second block. Also, the second block, the first block has close relation with the first block. And also, we say that the first block has a close relationship with the third block. Then the first block has a close relationship with the second block. Then the second block has a close relationship with the third block. I say look on the blackboard. Check your neighbor. What is your neighbor looking? So that is lines with arrows. Then how is the fifth block relate with the four blocks? Well, so it depends. But in most cases, we say that this block has a close relationship with this block. Sometimes it might be two-way or it might be one-way. So it can be this way or it can be this way. So when you get into detail, you'll understand. Depend. But generally, we just represent it by using a single arrow. It may, sometimes the information might be come from this block to this block or this block to this block. But for this one, the information already moving from the second block to the third block. This is just a literal numbering for the purpose of teaching. Okay? Then we have represented it, or we have showed the relationship between the 5 blocks. Next step, or the next, the third part? Labels. So the label for this block is called the input. We have discussed about that. The second block is called the what? Say loudly. Again, say control unit. The third block we name as a output what? Unit. Then the first block is called what? Oh, I forgot here. It should be written this way. I forgot. It will be written power supply unit. Edit it. Wait. Agape. So this one is called the power supply unit. Say power supply unit. So who can tell us the name of the fifth block? Pestuta, can you try? No. Angelica, can you try? Abraman, can you try? So Abraman is reviewing the previous here and there 10 examples of block diagram. So you can go and correct your 10 examples. Because I know you just see found them on, you just searched in Google, and then you went into the image, you drew the way they are. And then because you have the response, you are always asking the Sierra to ask him, when are we going to collect? Okay, this block is called the communication unit. It's called what? Say it's called what? Say communication unit. Say communication unit. So here actually we expect to have a transmitter, we expect to have a medium of transmission, we expect to have receiver. And a simple example, the microphone that I wore or I wear with the receiver integrated with the camera. So this is the transmitter, say transmitter, and that the receiver. And the medium is air. This is what he? Say transmitter. So within this block we have transmitter. Say transmitter. This is the transmitter. And then you have what? Receiver. Integrates into that microphone. But between the wireless transmitter and wireless receiver, we have medium. Say medium. And the medium is what? Air. You learned about wave. Mechanical wave. And what? We have mechanical wave and what? Electromagnetic what? Wave. So mechanical wave need medium for transmission. And sound is the one example of mechanical wave. Electromagnetic waves don't need what? Media for what? Where? You are not in the class. So this is still general. Say general. So you can find that within this block we represent generally or in detail 3 blocks. Transmitter unit, medium unit, receiver unit. But this is general. Okay? Yeah. And then a simple example. How does it operate? 5 principles. Can have 5 to 6 principles. Number 1, the power supply unit will power all the parts. And also, the power supply, because this communication unity needs power for it to work. Just like the transmitter you have. It uses batteries, and also the receiver uses batteries. So you can say that you have this junction, and also you have another junction. I say this, stop drawing. Check your neighbor. Okay, so with this general block diagram, how does it operate? Well, this is the general operation. The power supply unity provide power into the block of input unit, the block of control unit, the block of output unit, and the block of communication unit. I said I will not write the principle of operation. I'll just teach. Because my intention, you have to listen and you have to write. So this is listening. That's the first principle. The second principle, the input unit is always integrated with the real world environment. Remember that some of the blocks here might be used as the input. For instance, the antenna of your mobile phone may be used as the input to receive the information from the distant transmitter or from the medium of transmission. Okay? So it should not be crammed. So the input unit is always interfacing with the real world environment. Say real world environment. Just like my eye is interfacing with the real world environment, just like you, just like tables, just like desks, just like a blackboard. Okay? But when that information will be taken, my eye cannot define them. It has to send to the brain. And the brains give me the interpretation. This is Angelica and this is not Abrahaman. Right? This is Jackson and not Rhoda. Okay. So if that's the case, you say that once the input unit take the information from the real world environment, process. After that, it gives the output to the control unit. That's the second principle. The third principle, the control unity receives the input from the input unit and then process it, make decision, process it sometimes, amplify, reduce some noise. Where? I'm explaining the principal operation of this block. You are not listening and you are not looking. You are just concentrating with Musa. Okay. You will enjoy it one day. Then after that, the output of the control unit will be delivered into the output unit, and at the same time it will be delivered into the communication unit. That's the simple principal operation for this block. So for that case, we say that this is figure the general what? A general block diagram. General block diagram of 40 A of any electronics, telecommunication engineering. My friend is still in electronics engineering system. Engineering what? System. Okay? So listen. Let us take a simple example of a mobile phone. Take your mobile phone. Take your mobile phone. So your mobile phone, it has different blocks of the power supply unit. One of the block is battery. Say battery. Do you have Kiswasado or Fisher's mobile phone? You can access its battery. Yeah, very good. Elia or Elisha has it. Okay? So the battery is one of the components of the power supply unit in your mobile phone. There are also some other components, including surface mounting integrated circuit, which we call it a power or surface mounting device, or SMD, in power integrated circuit. But also we have a special IC that we call it a surface mounting device, or SMD, just charging integrated circuit. So once you focus into power supply units of the mobile phone, you can open this block and come up with a number of other blocks. Are we together? Are we together, class? So the power supply, okay, so that is number one. Number two, the input units we say microphone, another one, camera, another one, fingerprint, another one, keypad, etc. Control units is actual integrated circuits, or we call it microcontroller and other supporting integrated circuit, right? Output unit, we say it is what? A display, a speaker, touch, etc., etc., etc. That is. Then, if that's the case, well, that is good. Then let us talk about communication unit. Say communication unit. So there are different blocks of communication unit within your mobile phone, because your mobile phone is a transceiver. Say transceiver. Within your mobile phone, we have transmitter unit, and also we have receiver unit. Right? The input for the transmitter unit is an antenna, or we call it radio frequency or RF antenna. Say radio frequency or RF antenna. Previously, all the mobile phones, they had an antenna, which we call it a transceiver antenna. Previously, right? So this is a mobile phone and this is an antenna. Nowadays, we have PCB antenna. It's integrated within the mobile phone. It's there. Without that antenna, you cannot receive the information. That's all. You cannot access Wi-Fi. You cannot access Bluetooth. You cannot access calls. You cannot receive messaging. Hello? Okay, so that is communication unit. But also, we have a special integrated circuit in mobile phone that called network integrated circuit, or we call it a surface mounting device, aka SMD, network integrated circuit. Say it. Circuit. Say network. Say surface mounting device, or SMD, network integrated circuit. Yeah, it's not device IC, integrated circuit, excuse me. So integrated, so it's called network IC or network integrated what? No, Yes, A. Yes, I see. Integrated circuit. So you can, I think that from that discussion, you have noticed about what? About the examples of this block from your mobile phone, right? I saw Musa was writing the hands. However, that Musa is not listening. Maybe he will be asking a question that I've answered in my explanation. But let me give you a chance because I like questions from my students. First of all, is the concept clear? A. Principle of operation clear? Okay, good. Welcome Musa for the question, to ask the question. Musa, ask the question. I'm not teaching about transceiver, I just mentioned. So don't take this lecture series about types of block diagrams that I will teach about transceiver. Eh? Pardon? Transceiver is a combination of transmitter or is an integration of transmitter unit and receiver unit. That's all. So transceiver originates from the word transmitter and the receiver. Homework. Say homework. This is homework 3. I have prepared 3 questions for you. So draw the general block diagram of a radio. Question 2, draw the general block diagram of what? Of a television or of television. And they state its parts. Similarly here, and they state its parts. Question 3, draw, you had television at your homes, or you can access a television, a flat screen television in DH or dining hall or at cafeteria. So you have to go there and draw while you sit. Draw the general block diagram of what? Of a mobile phone. And the state its what? Its parts. So listen, how are you going to do this homework? Stop writing. Listen, how are you going to do this homework? You just draw what I've asked you to draw. And then, after labeling the figure, hello, I'm still waiting you. After labeling the figure, before you draw another figure, you have to state that for the radio, what are the inputs? What are the parts of the inputs? What are the inputs of radio? You have to state number 1, number 2, number 3, number 4, etc. Then you have to state what the control unit of the radio. You have to state what the output unit of the radio. You have to state what are the components of the power supply units of the radio. You have to do the similar business for the question 2 and also for the question 3. Is it clear? So you are not just supposed to draw, this is the power supply unity, and no, you have to state what are the components. For instance, in case of the mobile phone, we discussed that one of the components of the input is microphone. That's what you have to state. One example of the input unit for the mobile phone is a fingerprint. That's what you have to state. From there you will understand. And this is not actual a homework. This is an assignment. An assignment. So this is assignment 2. I will give you a week to do so. And you should not think that it's easy. It needs you to study and understand the radio, the structure of the radio, the structure of television, the structure of mobile. Are we together? Is it clear? Did you understand what you have been discussing? Class, I ask you, did you understand what you have been discussing, or do you not understand? Can you do the assignment now? I gave you 7 days. How many days in the week? 7 days. 7 days. 7 days. How many days in the week? 7. 7 days. 7 days. So it means 2 days, question 1. 2 days, question 2. 2 days, question 1. Another day, it's just for that. My friend is taking a photo just for the assignment. She was not interested with the notes. She was just relaxing and enjoying electronics drawing. So, did you understand the concept? Yes. Did you enjoy it? Yes. Well, so it's a time to congratulate you. This is the end of lecture 3. This is the end of lecture 3. It's time to congratulate you because you're 3. Hongereni. Imareni. Why in English? Good. Better. Bestie. Thank you very much. I would like to invite you, because some of the concepts, few of them or a lot of them I write down. Some of them I just speak. Okay? So it asks you to pay attention, to listen, and in case you have a question, I will be happy to see. So if you do this homework, at least now you have 6 examples of general block plotting diagram. It's not enough, but you have to advance it as well as you can. Okay? So I would like to thank God who have given me a chance to teach you. This is Olenjolai, a citizens of the kingdom of heaven and a citizens of beautiful country called Tanzania. Welcome in the next lecture, lecture 4. I hope to see you, and I hope to feed your mind in order to be transformed from ignorance in electronics drawings to mastering electronics drawing. So I wish you all the best. Thank you very much. May God bless you. In case you have a question, don't hesitate to ask in the comment section or in other different way. Thank you very much. Bye-bye.
Mungu ibariki Tanzania, dumisha